From the powerful flash of lightning to the subtle spark you feel, electric charge is a fundamental concept shaping our world. But have you ever wondered where these charges originate? Can we truly create them? Or do they simply move from one place to another? Today, we delve into one of nature's most profound principles, the law of conservation of electric charge, exploring how the universe maintains its perfect electrical equilibrium. Everything around us, from the air we breathe to the devices we use, is composed of tiny building blocks called atoms. Each atom contains a nucleus with positively charged protons and neutral neutrons, orbited by negatively charged electrons. When electrons are transferred from one atom to another, this delicate balance is disrupted, causing an object to become electrically charged. The law of conservation of charge states that within an isolated system, the total electric charge always remains constant. This means charge can neither be created nor destroyed. It can only be transferred from one object or location to another. Consider rubbing a glass rod with a piece of silk. Electrons move from the glass to the silk, leaving the glass positively charged and the silk negatively charged. Crucially, the amount of positive charge on the glass exactly equals the amount of negative charge on the silk, maintaining the overall balance. This principle is evident in everyday phenomena. When you rub a comb through your hair, it gains a charge and attracts small bits of paper. The electrons haven't been created. They've simply moved from your hair to the comb, causing the attraction. Even during a powerful lightning strike, where massive electric charges jump between clouds and the ground, the total charge within the Earth cloud system remains constant. Charge transfer primarily occurs through three methods: friction, conduction, and induction. Friction involves rubbing two objects together, causing electrons to move, as seen with the glass rod and silk. Conduction happens when charges flow directly through physical contact, like touching a charged object to a neutral one. Induction involves redistributing charges within an object without direct contact, simply by bringing a charged object nearby. Regardless of the method, the fundamental rule remains: the total charge within the system always stays constant. In an electrical circuit, electrons flow continuously, much like water through pipes. The total number of charges entering any point in the circuit is precisely equal to the total number of charges leaving that same point. This continuous, balanced flow is what powers our homes and technologies, all thanks to the conservation of charge. So, the next time you witness a spark, feel a static shock, or see a flash of lightning, remember it's not chaos. It's a testament to nature's perfect balance, where electric charges move and transfer, but the total score is always kept perfectly even. Understanding the conservation of charge helps us appreciate the intricate, balanced dance of energy that defines our physical universe.